Let's try this 2010 A-level paper 3. This is one of the more difficult mole concept questions for A-level over the years. Okay, let's start. Alcohol J is a volatile fungi metabolite whose presence when detected in air can indicate a hidden fungal attack on the timbers of a house. When 0.1 cm cube of liquid J was dissolved in an inert solvent and an excess of sodium metal was added, 10.9 cm cube of gas was produced. Let's write the equation. So you can see that 0.10 cm cube of the alcohol was used and 10.9 cm cube of gas was obtained. When 0.1 cm cube of liquid J was combusted in excess oxygen in an enclosed vessel, the volume was reduced by 54.4 cm cube. The addition of an excess sodium hydroxide caused a further reduction in gas volume of 109 cm cube. So when sodium hydroxide was passed through this gas, there was a drop in volume of 109 cm cube. This sodium hydroxide is a base, hence it is able to absorb any acidic gases. So it would have absorbed the carbon dioxide that was produced in the combustion of the alcohol. Let's write the equation. So the alcohol will react in oxygen or combust in oxygen to produce carbon dioxide and water. Since this is measured at 298 Kelvin, which is 25 degrees Celsius, water is a liquid. Let's balance the carbon first. I should put an X over here. Since there are Y hydrogen and one additional hydrogen, here this part should be Y plus 1 over 2. I'll let the coefficient for oxygen be Z. So 0.1 cm cube of the alcohol liquid combusts in oxygen to produce 109 cm cube of carbon dioxide. So we could tell because the sodium hydroxide, which is a base, absorbed the carbon dioxide, causing a reduction in gas volume of 109 cm cube. If you did notice, the amount of alcohol used in both reactions are the same. In fact, we can come up with a mole ratio between the alcohol, hydrogen, and carbon dioxide. Let's try. So the mole ratio between the alcohol is to hydrogen is to carbon dioxide. So 1 mole of alcohol will produce half a mole of hydrogen and X moles of carbon dioxide. And in this case, the volume of hydrogen produced is 10.9 cm cube. And the amount of carbon dioxide produced is 109 cm cube. Hence, we can see actually there is a relationship between the number of moles of hydrogen and carbon dioxide because the amount of alcohol used are the same in both reactions. I'm going to solve for X using mole ratio. X divided by half is equals to 109 divided by 10.9. That gives you x equals to 5. So we have solved for x. Now let's solve for y. Okay, but this is a bit more complicated. Okay, we're going to use this part 54.4. When the alcohol was burned in oxygen, there was a reduction in gas volume of 54.4. So under the change in volume, I'll let the amount of oxygen used up will be minus A, and the amount of carbon dioxide produced will be plus 109 cm3. We will ignore the alcohol and the water because those are liquid. We are only concerned with the gases. They say the volume of gas was reduced by 54.4. So oxygen, we don't know how much oxygen is used up. I let it be minus A. The amount of carbon dioxide produced is plus 109. I'm going to form an equation. Minus A plus 109 is equals to minus 54.4. The minus here is an indication of the reduction in the volume by the summation of the changes in the volume. This implies that A will be equals to 163.4. And hence, now we can actually calculate the value of Z using mole ratio and volume ratio. There is always a relationship between mole ratio and volume ratio for gases. In this case, X divided by Z is equals to 109 divided by 163.4. Imply, since we know the value of X, we can actually find Z. So Z is equals to 163.4 divided by 109 times 5. And this gives you a value of 7.5. So now, knowing the value of Z, we can actually calculate what is Y by balancing the oxygen. So when you balance the oxygen on the left hand side and the right hand side, there is 1 oxygen here and 15 oxygen here. So 1 plus 15 is equals to, over here we have 5 times 2, we have 10 oxygen plus this is the amount of oxygen, Y plus 1 over 2. Solving for Y, you realize that Y is actually equals to 11. There you go.